Hi, and welcome to this edition of Excel for Introductory Statistics. The topic of today's activity is z-scores, and the data that we're going to be using is the amount of snowfall in the city of Boston per year measured in inches. And our data is going to span from 1900 to 2021. So we have about 121 years of data to work with. Now, if you scroll down, you'll see our data goes down to all the way down to row 123. And so our data is here in column B, right? The year is column A, but the data we're working with here is column B, is the snowfall in inches. Now there's a couple of things we want to do with this data. The first one is convert each yearly snowfall to a z-score. Now, if you'll remember from lecture, a z-score is a unit of measurement. It's actually the standard statistical unit of measurement. Z-scores are measured in number of standard deviations away from the mean. So each individual data value, so those are our x values, has its own z-score. So in the year 1900, there were 25 inches of snow. And we'll convert that 25 to a z-score. It's not as complicated as it's sometimes made out to be. We could convert inches to feet. We could convert inches to miles. We could even convert inches to centimeters. That's what we're doing now. We're converting from one unit to another unit, converting from inches to number of standard deviations. Okay, so to do that, we need the mean and the standard deviation, and that's given. The mean is approximately 42.66. I say approximately because I rounded it to 2 decimal places. The standard deviation is 20.4. And our formula to convert an x value to a z-score is, well, we look at how far each x value is from the mean, and then we divide that by the standard deviation. Okay, so that's what we're going to have to do for each of these x values. 100 and a little over 120, I think 122 individual data values we have to convert to a z-score. Now on Excel, it doesn't matter if you're converting one number to a z-score or 100 numbers to z-scores. We only have to do it once. So let's start with the first snowfall amount in the year 1900. Let's convert that 25 to a z-score. So just for order of operations sake, I'm going to put parentheses because we want the subtraction to happen first before the division. So in that cell C2, I'm going to type in equal, and in parentheses, B2 minus the mean, which is 42.66, close parenthesis, and let's just get a little bit more room there, and we'll divide that by the standard deviation, so slash 20.4. Okay, so that'll give us the z-score for the first year, for the year 1900. So let's type that in exactly. Equal, parenthesis, number to the left. Remember, we're using locations of numbers. Minus 42.66, close parentheses, and divide that by 20.4. Now, it should make sense that we have a negative z-score because 25 inches is below average. 25 inches is below average. The average is 42.66. Now, for the remaining years, we could simply drag this formula down and have Excel repeat the process for us. number to the left minus 42.66 divided by 20.4. So if you hover the mouse over the bottom right-hand corner, click and drag, and we'll go all the way down to the year 2021. So now we have 122 z-scores. We did the first calculation, and Excel did the next 121 calculations because there was a repetition of the same calculation. Number to the left, minus 42.66 divided by 20.4. Okay, so now we have our z-scores, and that's it. That's it for z-scores. Now, one of the things, not the only thing, but one of the things that we could do with z-scores is identify values that are considered statistically unusual. Now, some books define this differently. Some books say 1 standard deviation away. It's pretty rare. Some say 3 standard deviations away. But most books consider a value to be unusual, statistically unusual, if it's more than 2 standard deviations away from the mean. That's precisely what a z-score is. It's just an abbreviated way of saying the number of standard deviations away from the mean. So when we look at column C, if you see any z-scores that are bigger than 2 or smaller than -2, then those years had an unusual amount of snow. And you know what? We could go ahead and put column C in order from, let's say, largest to smallest or smallest to largest. It doesn't really matter, but let's put them in order so we could see the really big positive z-scores and the really big negative z-scores easily. So I'll go to the home ribbon, sort. I'm going to go largest to smallest. And I'm going to expand the selection so the year and the inches follow along with the z-score. So wherever the negative 0.87 moves, the 25 is going to move to the same place, and the year 1900 is going to move to the same place. Okay, so what do we see? We see there are definitely some years where Boston received an unusually high amount of snowfall. So it looks like 7 years have snowfalls that have z-scores larger than 2. So 2.02, that would be the first unusually high amount of snow, and that happened in 1993. So we'll say these 7 years, and let's highlight them so we could easily identify them. These 7 years were unusually snowy, or these 7 years had an unusually high amount of total snowfall. And if we scroll to the other end of the list, we'll see if there's any negatives. So negative means below average. So the more negative, the more below average. And if we scroll all the way to the bottom, we see that there are no years that had an unusually low amount of snowfall. 1937 had only 9 inches the entire year. And even that, statistically, is not considered unusual because the z-score is only negative 1.65. Right? So that about does it for this activity. Just want to point out, remember, unusual values. So let's write this down. Unusual values have either a z-score above 2 or a z-score below -2. All right, so that's how we identify unusual values. All right, that is it for this video. I hope this was helpful.